Hello, Ross. In lesson 2.7, when we started talking about the generalized version of the chain rule, noticing that we'd been using the chain rule anytime we did a power of a function, I suggested that she kind of had some options when in a complicated function, that she could try composition before differentiation or just use the chain rule. What I want to advertise now is the option of sort of like decomposition. I guess the strategy could be called like variable substitution. Maybe it's a strategy you used before with complicated factoring. Let's try this question out by enforcing a composite function. Let's say given y equals 4x squared minus 3 cubed plus the reciprocal of 4x squared minus 3l squared. Let's find the value of delta y by delta x when x is equal to 1. So if you notice that in a function there's a repeated part, and this happens a lot in applications and in chemistry and physics and even in our course with related rates, then you have the option of trying to maybe simplify the question a little bit. Watch what happens if I let u be 4x squared minus 3. Maybe you recall in some of the approaches that I've used in previous videos that there was a lot of repetition when I had the same factor showing up. This is like an attempt to eliminate that repetition or to reduce that repetition. It does require communication, of course. Don't just expect your reader to figure out what you've done if this changes into u cubed plus u to the exponent negative 2. Now, the question asks me to find a value of delta y by delta x. I'm just going to demonstrate my understanding of the chain rule that's saying that I can link changes in y to changes in x through changes in any intermediate variable I want. I mean, I could put delta a if I like, but I have no idea what a is. U seems like a better choice. And the other way I can visualize this is I'm going to take the derivative of y equals something cubed plus something to the exponent negative 2 by doing the derivative of something cubed with respect to something times the derivative of something with respect to x plus the derivative of something to the exponent negative 2 with respect to something times the derivative of something with respect to x. One difference you're going to see here, though, is that if I use this approach explicitly, let's say, in the order that it's written, I'm going to have my expression of the derivative of something with respect to x removed as a common factor, which means it won't be repeated, which means I won't have to substitute in multiple times and calculate that value multiple times. These are all good things. If y is defined to be u cubed plus u to the exponent negative 2, then the derivative of y with respect to u is a simple two applications of a sum rule and the power rule, minus 2u to the exponent negative 3. The derivative of u with respect to x, just let's look up here, differentiate this expression with respect to x, differentiate this expression with respect to x, you'll get delta u by delta x here, and on that side you will get 8x. Now, this is an expression for delta y by delta x, so is this, but I mean, it's not an expression in terms of x. If you want to now substitute in u for 4x squared minus 3 for u, I feel like you're going about this backwards. You might as well have just differentiated in the original format. The advantage of this approach is that if we're trying to figure out the value of delta y by delta x when x is equal to 1, we could just calculate the value of u. As we let u be 4x squared minus 3, kind of regret this iteration, but what are you going to do? I wish that this value were different. Can I just go back and change this question without restarting this entire video? Let's find out. Change that, change that, change that. That's going to change not much else. Yeah, cool. The one concern that I had, I don't want you to think that the value of u is always the same as the value of x. That'd be silly, but it was unfortunate of my choice. So now notice that when x is equal to 1, u is going to be 7. It's going to make my expression a little bit larger, or smaller in this case, but we've got a calculator. We can figure this out. Your notation will also be a little bit different. This you can think of as like a multivariable function. To find the value of delta y by delta x, you're going to need to communicate what your value of x and what your value of u is. And you do that just like we did in class there. That's going to be 3 times 7 squared minus 2 times 7 to the exponent negative 3 multiplied by 8 times 1. Fine. Again, we really should be able to do this by hand if we take our time with it. Let's let the calculator do its work. Times 7 to the exponent negative 3. Can I get that as a fraction, please? Yeah, no. I want an exact value. Looks like I'm doing this by hand. 49 times 3, 150, 147. Oops. Yeah. Minus 2 divided by 7 cubed. I think we figured that out the other day. 343. That's multiplied by 8. Okay, let's get a common denominator here. 343, 343. So my calculator is a couple of years older, so it couldn't keep track of this as an exact fraction. This is because I didn't think out the problem ahead of time. I just wrote it. Times 147 minus 2. This will give me 50,419 340 thirds. Now I know 343 is a perfect seventh. It's a cube. It's a power of 7. 7 is prime. It's definitely not divisible by 8, which makes me feel pretty comfortable that this expression is going to be in lowest terms when I multiply this by 8 and get 403,352 340 thirds, I guess. Not my greatest example. Sorry. This is what happens when you change the question in the middle. But demonstrating, let's say, the flexibility of the chain rule. Do not avoid learning how to use the chain rule. Some students want to always just compose the function first, and they say, the chain rule is hard, so I don't want to use it. We're going to need it. There's a reason why it's being taught. Work with it now while it's okay, because it does become more important with applications.